Okay, welcome everybody. Are there any questions?
Sir, I have a question.
Yeah.
I actually had a chance to text, contact TA for the homework.
Okay.
Then the thing was that, well, if I check the last week's homework, there was two pages from WebAssign. And
Okay. Two questions or two what?
Two sectors I found out. And then the problem I found out is that from Khan Academy, the material we have to go through is was not the material we learned, which was like standard deviation this week homework.
Right. Yeah.
And then the amount of homework I found out is too beyond the control, I think. So I actually asked TA to to talk with the professors so that we can have a more flexible amount of homework. And then yeah, like I know we have to do all the homework, but I found that it's too much because the purpose of Khan Academy is to actually get a idea of what next week homework
Right.
that's right. But the extra
Right.
amount is too much, and then too really it was really hard material. Then I thought
Which was hard? Which part was hard? Which one? I mean, Khan or WebAssign?
WebAssign was fine because this is the material we've learned from
Ah, okay.
right.
Right. Okay.
For the Khan Academy, it's a material we have to study, but if you go through the question, it's actually more. It's not just getting idea. You actually have to think and really so that I talk. Yeah.
Okay. Okay. I actually, I had hoped that we would be going faster in our class and that we would have gotten up to the same place that you are in Khan Academy, but we haven't been able to go that fast in the class. So anyway, I understand, and I will consider what you say for sure.
Thank you.
In fact, let's just have a quick poll. I know this is a kind of silly thing to ask students, are we doing too much material? But let's do it anyway. Just see. It's kind of a silly thing to do because, but anyway, let's do it. Okay. And now let's see, how do you do this? Okay, let's see what you all have to say about this. Okay. Let's see, how do I end this? I end it like this. And let's share the results. Okay, so we can see what the opinion is. So I'll take the 14% as the best measure of the answer, though. No. Okay. Okay. Thank you for your comments also. So, all right, well, as I said, can you hear me okay? Oh, sorry. Right, okay. Okay, okay. So, all right, anyway, I was planning on slowing it down because, as I said, we haven't been able to keep up with Khan Academy. So you're kind of way ahead. And so I was going to slow it down. So, okay, I understand that. All right, let's go on today to continue. Now, I think I remembered that I said I was going to do RStudio, a little bit of introduction to RStudio. So let's do that for a moment. So let me show you. Let me share my screen. So hopefully you already installed R on your computer from last week, right? Everyone remember that you installed R? And can you see my screen now?
Yes, Professor.
Okay, so now it's a little better than working straight with R, or it is better than working straight with R, and that is to use RStudio. So what kind of, from Yun Seo, what kind of laptop do you have? A Mac. By the way, you are allowed to talk in this class. In fact, you're encouraged to talk.
Yes, I have a Mac, but then I downloaded it last time, but then it doesn't work for mine.
Okay, so if you go to download RStudio here, let's see, choose your version. So this is the version we want. Now, do they give us where do they tell us Mac? Let's see, download. Let's see, download RStudio here. Okay, so yeah, they have Mac. Did you download this one?
Yes, I did.
I think it works. I mean, I know it works. You know, R is being used by many Mac users, so it should work. But I don't know why it specifically didn't work.
I'll
on your
just download
computer.
it.
Professor.
Try it again though,
Thank you.
or do a little search for why it doesn't work. So I'm using a Windows right now, so I'm going to download this. If you're using Mac, you should download this. If you're using something else, you can find it in the list, hopefully. So let's just download this. Someone said try to search for an older version. So where would that be, by the way? Yeah, it might be the latest version doesn't work for some reason, but oh, here, older version of RStudio is here. So you could try that. Thank you for that comment. Okay, so once you download it, then I usually do it this way on a Windows. I'll open the folder and I'll run it as I'll install it as administrator. But that's up to you. You don't have to do it that way. But usually I'll do it that way. I'll do right click and run as administrator. But I'm not going to do it. But right now, actually, I've already installed RStudio. So you can just double click this and then just accept all the defaults. So you accept all the defaults and it just keep going next. And you don't have to do anything special and it will install. And then once it's installed, it's just like a better, easier way, or sorry, more convenient way to run programs in R. By the way, once you learn R, it's very easy to learn another very important, or well, another popular program in for science, and that's called MATLAB. But MATLAB costs money, so in case if you don't have someone to buy it for you, you may not ever buy it. But anyway, it's very similar. R is quite similar to MATLAB. Okay, so once it's installed, I'll bring it up by typing RStudio. And then hopefully it will open somehow. So when yours opens up, it's going to look a little different than this because I changed some of the viewing options. So what you can do is, does everyone get it open? Anybody need more time to open it?
Yes, please.
What? Okay, so the one thing is you can change the appearance of it. So you go to the top menus and there's one called Tools, I think. And you have Global Options. Global Options. You can't, who's Yu Chin? You can't open what? You can't open what? Oh, well, anyway, let's just go on. Okay, so you go to Tools and Global Options, and you get this. So if you want to change the appearance, you can click on this one here, Appearance, and you can change the color. Like here, you can do this, or you can do that, you can do this, do that, and so on. Okay? Oh, I forget what I had. I think it was that one. Okay, and then you can change the font here, and you can change the editor font size. And then you can also go to Pane Layout, which is here, Pane Layout. Well, you may not be able to get it to work right now. It's not too important, but it will work eventually. Okay, so you go to Pane Layout, and I suggest here you put the console. I mean, it depends, you can do anything you want, but if you want it to look like mine, you put the console here and the source here. So that's here and here. And then you have environment here and files, plots, packages here. And you can have files, plots, packages, help, and viewer. So something like this. Since we're not really going to use it much, it doesn't even matter, but I'm just telling you what you might do. Okay, does everyone get that? What's the spelling? I've never seen that before. Custom dictionaries, ignore words. Okay, all right, and then you just click apply. It'll work, eventually it'll work, I promise it'll work. Okay, click apply, and then you'll see something similar to what I have here. Now here, you see these two little buttons here. So if you click this window I think will kind of hide. So if it doesn't work, just follow what I'm doing. So there, I hid the bottom window, and then I can expand it. And whoops, I guess, let's see. There, like that. Okay, so if you remember, we did something like x equals c 1, comma 2, comma 3, comma 4, comma 5. So try and, but actually actually, let me copy that. I did that, we actually did that up here, really. We weren't using RStudio, so we didn't do it here at all, but this is the same window that we were working with last time. So every time you type something in here and you hit return, R will perform what you do. So that's what we did last time. We did something like x equals that, and I hit the enter key and I get that. Okay, and then if I want to see what x is, so remember last time we said we created this variable x, and it has these numbers in it. So if I want to see that, I type x and return, and then you can see that. Okay, and then if you want to do the median of x, you can do that. Or yeah, the median is going to be 3, right? So you can type median. Or you can type mean of x, and you will also see 3. Okay, now I wonder if this works. I forget. Plot x. What happens? Yeah. Okay, so it will plot those points. Let's do a z equals 5, 4, 7, 9, 2. Okay, everyone can do that. Z equals 5, 4, 7, 9, 2, and hit enter. And I did something wrong. What did I do wrong? Anybody know what I did wrong?
I did
You
not
missed the C.
complete the bracket.
What?
You
Did
missed
not complete the bracket.
No, I did complete the bracket, actually. Look, I have both there.
You didn't put the C.
You
Right,
missed the
I
C.
didn't put the C. So it's always, you're always going to be making mistakes. Not, if you're like me, you're always going to be making mistakes. If you're not, maybe a lot of people don't do that. But anyway, always these kinds of things happen. So I forgot the C. So I'll put the C in there. And now I don't get that error anymore. Okay, then Z, if I type Z, I get 5, 4, 7, 9, 2. Okay, and then I can plot Z, plot Z. Okay, and that's going to look a little different than the previous plot. Okay, so it's the first value is 5, the second value is 4, 3, 2, and 5. Now, you can also do, if you, like, I can't remember some of the details of this plot function. I can't remember. So what you can do is you can type question mark and plot, and it will show you some help file about plot. Now, reading R's help files is not easy, but I'm going to do it. Plot. I hit enter. And over here, it shows me kind of two choices. So it's not so simple. R always kind of assumes that you're a genius when you're working with it. So default scattershot, or this one. So I'm going to do this one. I'm going to get help on this one. Okay. So this is help. And it's kind of, as you can see, it's like impossible to understand for somebody who's just coming to R. But here, what they do is they tell you the plot function, and then they tell you all these different kind of extra things you can put in if you want. So all I did was put in X or Z. All I did was put in the data. But you can also put in other things. So one other thing that I can put in is Well, I could put a label. No, let's see, where's that here? I could put an X label and a Y label. So if I want to do that, you can add that in. So what you would do is you would do, oh, by the way, one good thing about R is instead of retyping things, you can hit the arrow key. So here's my keyboard, and you can hit this up arrow key here, and you'll go back. Watch when I hit it. I'm going to hit 1, 2, 3. Now you can see on my screen that it went up, and then I hit it again, and it goes up to the previous. So you can scroll through the previous things that you type. So all right, so I have that. So now I'm going to put comma, and I'm going to use this X label and Y label. So I'm going to do X lab, or X label equals, let's say, time. And I'm going to type, whoops, I'm going to type Y lab equals, let's pretend it's cost. Okay, so now let me run this. So I'm going to hit enter again. Okay, so now you can see that these have been labeled as time and cost. Okay, now R has really great graphics ability. This is not really great graphics ability, what we're doing right here. This is, pretty not so beautiful. But anyway, we don't want to spend a lot of time, but you can learn how to make textbook style plots in R. Okay, so there's a plot. Now I forget though how to connect these. Like suppose I wanted a line that connects them. So if I go back here to help up here, so I'm on the plots here, but if I go back to help, this is the help that I was just looking at. And here it explains what all those things are. Like it tells us that X lab is a label for the X-axis, and Y lab is a label for the Y-axis. So it tells us that. But I wonder, and then if you scroll all the way down, it gives you some examples of how to use it. So I'll try their examples. So I'm going to, let's see. If I type it here, you can see it says cars. So let me type cars and see what happens. Okay, so some data is already installed in R. So there's certain data sets that you can already play with in R. And I guess what cars is one of them. So I typed cars just to check to see if it was already there. And it was, and it showed me it shows me what cars is. So cars has speed and distance. So I guess the speed was 4 and the distance was 2. I don't know what this is, but anyway, this is some data, cars. Now, is everybody following me so far? Anybody have any questions so far? Even if you can't install it yourself, does oh, somebody got an error. Error flag. Oh, you forgot the equal sign. You're like me. You forgot the equal sign on Y label. Right? Did everyone see his error? He typed in this, but he forgot this. So he got an error. Right? So, okay. So it's easy to make mistakes. I do it all the time. Hopefully you won't be as bad as me, but you'll probably make mistakes. So anyway, so you got some error, but okay, so cars, okay? So I have cars here. Cars is available. Now you can see this is one column and this is a second column. Does everyone understand? This is one column and this is the second column. And we call this is the first variable in the cars data set. And we call this the second variable in the data set. So if I want to access just the first variable, I don't want to get all of the data, I just want the first variable, I can type cars, I can do this. Here it is over here. I can type cars $speed if I just want speed. Anyway, it definitely works with Mac. Believe me, I promise it works with Mac. But anyway, right now you don't need to worry about it. So let's try that. Let's type cars. I'm just going to copy this, in fact, instead of typing it because I'm lazy. So I'm going to type cars like this. Okay, now this is a special R sign, but it's basically the same as this, as equals. But usually people type that other sign instead. So let me undo what I have. So I'll just leave it the way it is. You could, but you don't need to do that. You can just type equals. There's like one very rare case where they're not the same, but you won't have to worry about it. Okay, so what is this telling me here? It means this means I only want the speed column of the cars data set. So you do that with this $sign there. So this is from the cars data set. I only want the speed column. That's what you put a $sign in front, and that does that. And now I'm going to assign that to a variable called speed. So let's try it. Hit enter. Okay, and then if I type in that variable, speed, and I hit enter, you can see those are all the entries of, you can see like the last entry was 25, and you can see the last entry here was also 25. So that's the speed variable. Does everyone understand this so far? Now, you might be confused by this number and this number and this number. Let's see if anybody can figure out what this number means. What does 18 mean? See if anybody can figure that out. It's not obvious. I mean, but you can figure it out though, or somebody within our 75 students here. Probably there's somebody who will guess what it or figure it out.
Professor?
Yeah.
Maybe it's about quartile ranges?
What?
Quartile ranges.
I can't hear you.
No, you can hear me. Okay, I'm gonna write.
I mean, I can hear you, but I didn't hear what you said exactly. Anyway.
Can you hear me now?
Anyway, what it means is this 13 is the 18th element in our list. In other words, if you count, this is the first, the second, the third, the fourth, the fifth, and if I keep going, this is the 17th, and this is the 18th element. Okay, so that's all it means. It's just like if you have a long list, this kind of tells you where you are in the list. Okay, does everyone get it? Okay, anyway, so we have speed here. Okay, let's see what else they did. Now, let's do the same thing for distance. So let's take cars, $distance. Remember, we had a second variable called dist for distance. So let's copy this one and put that in here as well. So now I have a variable called distance. Let's check it, distance. Okay, it looks like that. Does everyone get it? Okay, now let's try the plot with these two variables, with speed and distance. So they do that, and they fill in a whole bunch of extra options here. So that's what I want to see. I want to see what their options look like. So let's try this. So I'm going to copy it and put that here. So speed and distance are what we're going to plot. And then there's some options about colors and I don't know what else. So let's see what it looks like. Okay, so that's what it looks like. So now we have on the x-axis speed and on the y-axis distance. And I don't know what this is, but what is it? As the speed increases, the distance increases. I don't know. So these are cars. So some car data that looks like this. Okay, does everyone follow this? Let's try another one of these. Let's go back to the help again. Up here, I click on help again and see if there's any other interesting plots here. Here's one more. Let's see what this does. This also uses speed and distance, but the other options are, I guess they're different. Let's see what that looks like. So I'll copy this one and put that in here. Let's see what that looks like. Okay, so that one put a line in there somehow. So that's a little bit more interesting. So anyway, this is the kind, now let me see. Oh, I think if I do demo, what's this, demo? No, let's try demo plot. No, let's try. No, there's some way to look at demo of the. Let's look that up on the internet. Let's try that. Let's see if I can find that. Demo plot R. So how do I run an R demo? How do you plot an R demos R package? The R graph gallery. Let's see about that. Well, this is different, I guess. I wanted to get something going in R, but you can see lots of different kinds of graphs that you can make in R. So if we click on one of these, like you can make maps, I guess. A background map, let's see. So you can make pictures like this in R, and these in R, and so on. But I wanted something else. What's it called? R. Let's go back once more. R demos package. I forget how to do it right now. R graphics demo.
One of the areas where R excels is
Maybe it's
graphics.
demo graphics. Let's try that. Demo graphics. No. It wants to automatically fill in stuff here. Okay, just type return to start. Okay, I'll type return. Maybe I have to go to here. Plot. Okay, hit return to see the next plot. Let's try that. Okay, so here. This is, I guess, what I was looking for. So you can see here some sample plots that you can draw. I'll hit enter again to see another one. So that's another type you can draw. Another type. Another type. Another type. Another type. Another type. Another type. Anyway, there are many, many types. These are only a tiny sampling of what you can do. or graphics. Okay, so that's that. Okay, so, and then here, so that was in this window up here. Now, you may not always want R to evaluate what you've typed right away. You might want to type a whole bunch of stuff and then later ask R to evaluate it. So here, every time I typed, like, let me go back to here. So every time I type this, R is going to run it, and it's going to assign this to this variable. But I may not want to do that right now. So instead of typing it in this box, I can type it in this box here. So now nothing happens when I hit enter. It just goes to the next line, just like any text editor. So that's when you want to type a whole list of lines and then run them later. So that's what this down here, which is called the source window, is for. So if you just want to type a bunch of commands and then run them later. So if I want to run this later, I can either run everything in here, or I can just run one line at a time, or just several lines at a time. So I could do this and this one together by just selecting them and click run. And then they would run. But otherwise they don't run. Okay, so this is RStudio, and it's much easier to work with than R is by itself. Now, one more window here that I want to show you, and that is here. These are all the variables that we created. So we created a distance variable. We created, maybe we didn't know that we created all these, but I guess when we ran this, this demo, we created some other ones. But we also created a speed variable, and we also created an X variable and a Y variable. Okay, so this lists all the objects that you've created in your session. Okay, so that's a very quick introduction to R. And then if you want to save what you've done, basically that means save all these things that you've created, so you don't have to recreate them next time. When you go to File and Close or Quit, it will ask you if you want to save it. And then you have to think about where you're saving it to, and you can organize things so that you can save one set of things for one thing and another set of things for some other project and so on. But anyway, either you want to save it or you don't. So you can either click Don't Save or Save. So I'll click Don't Save. Okay, anybody have any questions? So you can use R sort of the way you can use Excel. So you can find the mean, you can find the median, but you can do a lot more advanced things with R than you can with Excel. But Excel is, has its own benefits, but R has its own benefits as well. Okay, anybody have any questions? Okay, let's start with the lectures today. So let's start with this lecture here. And then we'll have I think we'll have a short quiz on this one. So let's start with this. If you can't hear, let me know. Okay, we're just going to rush through these following sections. Oh, did we do this last week? About being honest when you're doing statistics? Did we cover that last week? Or cheating when you're doing statistics?
I don't think so.
Okay, yeah, right. I think it was the other class we did it. Okay. So descriptive statistics is basically, usually we divide statistics up into two parts. So the first half of a class would be descriptive statistics, and then we do something called statistical inference. So that's where we use things like regression. We are actually going to get to regression, and then people do things like big data and data science and machine learning. That's kind of an offshoot of statistical inference. So descriptive statistics is when we just kind of take a set of data and try and describe it. So we talk about what's the mean of a variable, or what's some other measures or just summarizations of variables that we will see. And then, as I said, the second half of a course would be statistical inference. We actually won't have time to go that far, but you'll have the tools to follow up on it if you need to. In this section called Analytics, this is maybe a course that we have called Data Science or Data Mining, and then we also have some courses that follow up on that. So that's when we do things like what we would call analytics, descriptive analytics, predictive analytics, and so on. Okay, we don't need to talk about this right now. Okay, we will be using Excel, and we will also be using a programming language called R. So we'll get to play around with both of those. Okay, let's very quickly talk about ethical guidelines in statistical practice. So they talk about an example here. Here they say, let us consider an example. In section 1.5, we discussed a statistical study conducted by Rogers Institute involving a sample of 200 lithium batteries manufactured with a new solid-state technology. The average battery life for the sample was this. So this is how long these batteries by Rogers Institute involving a sample of 200 lithium batteries manufactured with a new solid-state technology. The average battery life for the sample was this. So this is how long these batteries last. And this provides an estimate of the average lifetime for all the batteries. So we had a sample of 200, and their average was this, 18.84 hours. And so we might guess that that's approximately what the average lifetime for all the batteries that this company produces is. They say it's reasonable to assume that another sample would have provided, on the other hand, would have provided a slightly different battery average, but because of course each sample will give a slightly different version of the average. So now they give a kind of scenario where a kind of unethical set of practices that Rogers might follow. So they say, suppose Rogers management had hoped the sample results would enable them to claim that the average time until recharge for new batteries was 20 hours or more. Suppose further that Rogers management decides to continue the study by, so they're going to, continue the study by manufacturing and testing repeated samples of 200 batteries with the new solid-state technology until a sample of 20 hours or more is obtained. So what they're saying is, first time they took an average, they got this, but of course if they take another sample, they're going to get a different average, and then they could keep checking samples until they got a sample whose average was 20 hours, and then they could say, okay, so our technology produces batteries which last on average 20 hours. Is that fair? Of course, that's not fair. They say if the study is repeated enough times, a sample may eventually be obtained by chance alone that would provide the desired result and enable Rogers to make such a claim. In this case, consumers would be misled into thinking the new product is better than it actually is. Clearly, this type of behavior is unethical and represents a gross misuse of statistics in practice. So there are many ways that you can imagine or that you can figure out to sort of mislead people with statistics, but of course, hopefully, we don't go down that route. Okay, now we're going to do chapter 2. So we can see chapter 2.1, 2.2, 2. And so on. Most of these have to do with summarizing. So we want to summarize data. And we're going to talk about summarizing a categorical variable, then summarizing quantitative variables, and then summarizing two variables together using a table, and then summarizing two variables together using graphical display. So that's what we want to know here. Okay, so let's take a look at that. So we talk about something called a frequency distribution. So here we have some data. What is this? We have a sample of 50 soft drink purchases. So sometimes it's Coke, sometimes it's Diet Coke, sometimes it's Dr. Pepper, and so on. So this is the data. Now this data is clearly not numeric, right? It's a purchase. So we might say the variable is purchase, and the different possible values are not numbers. One possible value for purchase is Coca-Cola. Another possible value for purchase is Diet Coke. Another is Pepsi, and so on. So this is a categorical variable. So how do we summarize this categorical variable, or how can we summarize a categorical variable? So one way to do it is this. So we say how many occurrences of Coca-Cola were there if you count all of them. Turns out there are 19, I guess. How many occurrences of Diet Coke are there if you count all the Diet Cokes? Turns out there are 8. Dr. Pepper, 5, and Sprite, 5. And if you, of course, you sum those all up, you should get the total number of the sample size, the size of the sample, which is 50. So this table here is called a frequency distribution. So it tells you the frequency over each of the possible values that the variable can take on. So it can take on the value of Coca-Cola, Diet Coke, Dr. Pepper, Pepsi, and Sprite. And this is the frequency of each of those. So it's called a frequency distribution for this variable, soft drink purchases. Okay, so this is the frequency distribution for the soft drink purchases. Okay, let's have a quick quiz on this. So let's, if you look on Manaba, you'll see, I'm not going to send you reminders here because I think I'm just filling up your email box with reminders, so I won't do that. So let's go to groups and breakout rooms. Okay. So let's go to breakout rooms and then do this one together. You only have a short time to do it, but go ahead and do it. Did I turn it on yet?
Professor,
Yes?
I think you didn't turn on the quiz.
Oh, yeah. Okay, I will do that.
Okay. Okay.
you- The one you just made, right?
Yeah, the one that I just made. Or you turn on the another one.
What's that?
So you turn on the another one, or you want to turn on the one I made it?
No, I turned on a different one.
Oh, okay, okay. Sorry, Professor.
And I'll turn on the one that you made.
Oh, okay. Sorry.
Good.
Professor.
Thank you.
Professor,
Yes.
I just had a concern with Khan Academy. So it just shows that even though there are some of the videos that I've actually seen, and I've actually completed the quizzes after that video, it still says that my assignment is late.
Oh,
Professor, I can't submit.
you can't submit what?
Page not found.
Quiz?
After I press the submit button, like the page turns into like not found.
All right, I'll open it, but you have to do it before you leave the room.
Yeah.
Okay, it's open now. You can try it again.
Oh, okay. You open 了。
Okay?
Yeah.
Okay, can I close it?
Yeah, thank you so much, Professor.
All right, so what, the first one is what?
又不行，哎，我真无语啊！
What? No, the first one is what?
False.
That's false.
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 Right. And the second one, if you sum up all the frequencies, you get what?
Number
2.
Okay, good. Okay. All right, let's have a individual test. So I'll turn that on now. Okay. So give that a try. And you have 25 seconds left. Okay, I'm going to turn it off, close it. Okay. All right, let's go to the next video here. Okay, so this is the frequency distribution for the soft drink purchases. So this is the frequency distribution for this categorical variable. So suppose I wanted to know, I asked what percentage of the total purchases is Dr. Pepper. So you see there were 5, and the total number of elements in our data set is 50 soft drink purchases. So if there are 5 that were Dr. Pepper, okay, somebody's video is on. I mean, somebody's mic is on. I don't know how to mute everybody. Yama-san, do you know how I can mute everyone?
Okay, Professor, I will do.
No, can you just tell me how to do it though?
Which one?
How to mute everybody.
So it's a go to participant and then mute all, Professor.
Ah.
Yeah.
Participants and
when you open participants, so they pop up, there's like a box, so you can mute all.
all right. Okay. Thank you so much.
You're welcome, Professor.
Okay. But actually, yeah, so you can unmute yourself. Okay, good. Okay, let's continue with this. Number of elements in our data set is 50 soft drink purchases. So if there are 5 that were Dr. Pepper, that's 5 out of 50, which is 10%, right? So that would be, we would say that this is 10%. And how about for Sprite? It would also be 10%. And for the other ones, we could figure them out. So in the next section, we talk about doing that. How did we calculate that? We took the 5 and divided it by the 50. Okay, and that's called the relative frequency of the class. So we take the frequency of the class and divide it by the total number of elements in the data set. So here we get those numbers. Here's the 10%, and here's the 10% for this one, and the other ones are given here. And then if you want to talk about the percent frequency, you'd say this is 0.38, so the percentage is 38. This is 0.16, so the percentage is 16. So you could. Okay, does anybody have a question about this?
No, Professor.
Okay. Give the percent frequency as well. Okay, let's have a quick quiz on that. This is just an individual quiz. Oh, sorry. No, we won't have a quiz on that. I only have a group one for that, and I'm not going to do that. Okay, so here's the same frequency distribution that we saw originally for this data. So how could we make a picture of this so easily? So we could do this quite easily. We just start out like this. We say Coke, then we said there were 19. We find the, well, we can do the count 19. So we have another axis here. Like that. Maybe 19 is over here somewhere. And then we just have a bar here. Goes as high as 19. And then Diet Coke is 8. So we'd have some 8 here, something like that, and so on. So this we can do. And so this would be called a bar chart. So we have Coca-Cola at 19 and Diet Coke somewhere else, and Dr. Pepper somewhere else, Pepsi somewhere else, and Sprite somewhere else. And they do a sorted bar chart, so we don't really have to keep this order. This was sort of an arbitrary order. So we could put Coke first, but then we could put Pepsi second, and we could put Diet Coke third, and so on. So we could reorder it like that. We can also do what's called a pie chart, which looks like this. So it says Coke has 38%, and Pepsi has 26%, and so on. And we could do this picture as well. Okay. Okay, if you want to do something like this in Excel, here I just made up a similar data set. It's not the same numbers, but similar data set. So you just go to Insert, and then there are a lot of charts here. You can use a recommended chart, or you can just click any of them here. Let's see. So you can either choose the recommended one. So here's a recommended one. We can go to all like that and get many different types. But if we just stick with the recommended, we have this one, I guess, which is here. And click OK. And we get that. So that's basically what they showed us as the frequency distribution. And again, if we want to do it again, we can go to insert again. And this time we can try recommended. And this one, we get that. Now it doesn't label them. So if you want to get the, we can move around here and you can see what the labels are. But I guess you have to right click on it and do some other stuff in here to get the labels on these pieces. Those are probably optional. And then if you want to get the relative frequency, then you might, first you're going to need to know the total number of elements here, because remember we had to divide each of these by the total number. You can get the total number by going to the home ribbon and then going over here to auto sum. This is one way to do it. And just click auto sum, or you can choose from the options here, but we want the sum. You could get the average and these things, but we just want the sum. So we'll go here and hit enter. So the total is 30. So now we can do, we can write equals. You have to write equals this divided by this. Okay, and that will give you the relative frequency for that one. Okay, let me ask you, what would happen now if I took the mouse and put it up here and drag this down to here? Would that give me what I want or not?
It will be the relative frequency.
You think so? How many people agree with that? How many people agree? So you think I can just take this and then drag it down and it's going to work?
No, it does not work.
Okay, so somebody said it doesn't work, but some people said it does work. Can everyone hear me, by the way?
Yes.
Let's see what happens. Let's see what happens here. And then you could do equals this divided by this again. And that will give you that one. Now, you might want to just drag this down. Unfortunately, that doesn't work. Watch. When I drag this down, I get these, which don't seem to work. The reason is because when I drag it down, it's calculating. So let's check this. Let me just say, when you drag it down, what happens is any numbers in your formula will increase, because as you go down, the row numbers increase, and the numbers in the formula refer to the rows. If you drag it to the right, then the columns increase, so the D would increase, and this D would increase. But I'm trying to drag it down, so the numbers will increase. That is, the 3 will increase and the 8 will increase. But what's wrong with that? What's wrong with having the 3 increase and the 8 increase? So I'm starting with this formula here, which was D3, or this one actually, is D3 divided by D8. Is that the correct calculation or not?
It is a correct calculation.
Yes, it is the correct calculation, right? D3, that's this number here, divided by D8, that's this number here. That's what I wanted, right? Everyone agree?
Yes.
Now what's going to happen when I drag down? I just said the numbers will increase. So you think, okay, maybe that's a good idea. So what happens when I drag down? If I drag down one more, what happens? If I go from here to here, these numbers will increase. So the 3 here will become what?
4,
And the 8 will become what?
9. Anything is wrong.
Yeah, that's wrong. What's wrong? The 3 is, sorry, the 3 becoming a 4 is correct, but the 8 becoming a 9 is wrong, right? There's nothing in 9. Is that clear?
Yeah.
Yes.
So that's not going to work. One was D3 divided by D8. That's good. This one was, oh, sorry, here's D3 divided by D8, right? This is D8. That's what we wanted. Here, this one is what? D4 divided by D8. That's also what we want. D4 is here. But that's what we want, but I didn't get that by dragging down, right? I just typed that one in. But next I drag down. Divided by this one, D8. That's what we want. But here, when we do this, what's it doing? D5, we do want D5, and it's dividing but by D9. That's not what we want. We want it to keep dividing by D8. So when you do this kind of dragging down, when I click here and I drag down, or if I click here and I drag down, it increments not only the so the 4 becomes a 5, right? See, let me show you that again. The 4 becomes a 5. That's good, but the 8 becomes a 9. That we don't want. We want that 8 to stay 8. So how do we get that? How do we get the 8 not to change?
So hit F4.
What?
Hit F4 after after the D9. Hit F4.
F1, F4.
4, yeah, to
Really?
make the fix.
I never heard of that.
In my opinion, we should select the first and second goals and then drag it down.
I don't know. I don't think that works. I'm not sure. I don't know about the F4 either. I'll have to check it. This is not a spreadsheet. This is just a video, so I can't click in here. But let's see. Let's see the other way to do it, or the way to do it. I don't know. Let's see. It's 9. We don't want that. In fact, here it becomes 10, and here it becomes 11. We don't want any of those because that's here, here, and here. We don't want any of those. So what you need to do in order to get Excel not to do that is it's kind of a strange thing, but put a $sign in front of that, the thing that you don't want to change. So, okay, notice that we're in cell E4, right? Right? And it says D4, D8, and then I put the $sign in there. Now, if I drag that down, that number will not increase, will not change. Okay, so it's always going to read that D $8, D $8 for all of these. Now, the only Excel ignores that $sign except for when you're dragging. In other words, it still reads it like D8, but if it's dragging, it knows not to change it when you drag down. So I don't want the 8 to change when I drag down using this kind of drag down process. Now, if I use the $sign in front of there, it still works here. It's still going to give me the right number. If I hit enter, that's the same number that we had before. So basically it ignores the $sign except for the dragging down function where it keeps it constant. So now if I drag down, I get what I wanted because this is still 8. This one is also still 8. And this one is also still 8. So now it works. So that's how Excel, they wanted to have this drag down function. This is how they told the drag down function not to increment certain values. Okay, does everyone get this?
Yes.
In fact, we can check by taking the sum of these. Since these are the percentages, the sum should add up to 1. So let's make sure. Just click here and click enter, and it's 1. Okay, so we can, then we could also make a bar graph with this data. I guess might be good too. So one thing you might want to do is delete this column, but that's going to, well, let's do it. Watch. When we delete this column, the other one is going to get messed up. Why is it going to get messed up? Because when I delete this column, the calculations were based on this column, and this column is going to disappear. So this is, we're going to have an error in this column, but let's just see that. So go to here and delete. It says we're referring to something that's wrong. So let's undo that here. And what you can do instead is, so we have these values, we calculated them. You can copy them and then repaste them back in here, but not as the formula, but just the values themselves. So once I do this, which I'm going to do like this pasting here, repaste just the values. But once I do that, now if I check in these cells, I don't have those formulas anymore, I just have the values. So it's not a formula anymore. Now, if I delete this, I won't get that problem, hopefully. Seem to have a problem, but oh well, let's just leave it. Okay, it seems like it's right. This, of course, doesn't seem to be good. I don't know what happened here, but we can try now to make, let's give this a name. Let's call this relative frequency. And we can do this and make it inserted chart. This time it's going to look pretty similar to the other one here, but these are going to be percentages now. Before they weren't percentages. Okay, so you can do this kind of thing in Excel. Okay, so what if we have, okay, if you want to do something like this. Okay, so what if we, okay, let's have a quick quiz on that, on something. So let's do just a group, not group, just individual. So I'll just turn it on. Even it says it's group, but just do it as an individual. Okay, so go ahead and try that. And you have 30 seconds. Okay, you have 10 seconds. Okay, I'm going to shut it down. Okay, let's go to the next one. Have a quantitative variable like this. So here they say the year-end audit times. And this is that it shows the time in days required to complete year-end audits for a sample of 20 clients of this company. So the idea is that this company is called Sanders and Clifford, and they do audits of other companies. That means like they check their books or something like that. And, you know, so it takes time to do an audit. You know, you can't just like do it in 5 seconds. You have to go and ask many questions and talk to many different departments and so on. So it takes time. And so this is how long it took to complete an audit for 20 of their clients, 20 different clients. So it took 12 days for them to complete the audit for one company. It took 15 days for them to complete the audit of another company. It took them 20 days to complete the audit of a third company, and so on. and there are 20. Let's say there's 4 by 5, yeah, 5 by 4, so there's 20 elements in this data set. Now, suppose we want to make a frequency distribution for this kind of data. So basically, this is what we're aiming at. So what this says is that there were 4 companies that it took between 10 and 14 days, and there were 8 companies where it took between 15 and 19 days, and there were 5 companies that took between 20 and 24 days to audit, and 2 companies between this and this, and 1 company between this and this. And when we add all of these up, we should get all 20 companies. Now, you would say, well, why did they choose 10 to 14? Why didn't they choose 10 to 13? Why did they choose, 15 to 19? Why not some other interval size there? And actually, that's kind of a choice that's left up to you. So there's no hard and fast rule for that. So once you decide these intervals, so say 10 to 14, 15 to 19, 20 to 24. Now you can see that all of these are of the same length. So this is of length 4. This is also of length 4, and so on. But even that doesn't have to be true. Usually it would be, but it doesn't have to be. So they call these what I just called intervals, they call them classes. So we can see that there were, this is the first class, the second class, the third, the fourth, and the fifth. And they suggest making 5 classes, they suggest making between 5 and 20 classes. But in this example, they had 5 classes, right? 1, 2, 3, 4, 5. 5 classes. Now, if you're going to have all of the classes have the same width, which is, I said, not necessary, but usually you would want that, then to get the approximate class width, you take the largest data value in your data set minus the smallest and divide that into the number of classes. So like in our example, I think the largest is 33 and the smallest is 12 maybe. So we would do 33 minus 12. And then if we're going to have 5 classes, you would divide by 5. So you get 33 minus 12 divided by 5 is 4.2. So you say, okay, the class width should be about 4.2, but you don't want to make it exactly 4.2. That's going to make it very clumsy and a lot of extra work. So we just make it 4, not 4.2, the width. So therefore, I guess since the lowest value was 12 and the width was 4, they start at 2 below 12. They have the smallest piece of data be the center of the first interval. Looks like that's what they did. So you would go from 10 to, so in other words, 12 minus 2 and 12 plus 2. So that's probably how they get 10 to 14. And once you start at 10, then you go to 14, then you start 15 to 19, and you get 5 classes. You should cover all of the data. So we talk about the class limits. So the class limit is 10 and 14 here. The class limit for the next one is 15 and 19. So the class limits must be chosen so that each data item belongs to one and only one class. So you don't want to have 10 to 14 and then 14 to 18. Because what would you do if you had a data value that was 14? You wouldn't know whether to put it in this class or this class. So they say we want each data item to belong to one and only one class. And the lower class limit identifies the smallest possible value, and the upper class limit the largest possible value. Okay, so we just did the frequency distribution for, okay, let's have a quick quiz on that. And I'm not going to do group because we're running out of time. So let's go on to just individual. So you should see it there. So you have 30 seconds from now. Okay, 5 seconds. Make sure you get it in. Okay, I'm going to shut it. Okay, let's go on. For a quantitative variable, we had this data, which we split into classes, and we got classes like this, 10 to 14, 15 to 19, and so on. And we counted up how many elements are in each class, and we got these numbers, and the total number of elements altogether was 20. That is, our data set contained 20 elements. Now we go to relative frequency and percent distributions. So now we just take those relative frequencies, which were, again, right here, we take the frequencies, sorry, and we divide by the total number of elements in the class, in the data set. And so we divide by, what was it, 20, I think? And so we divide these by 20, and we divide these by 20, each one of these by 20, and we get these numbers here. And then we can divide, then we can write this as percentage if we want. Instead of 0.20, we can write it as 20%. Instead of 0.40, we can write it as 40%. So here is another way to display the data, or here's a way to display the data that we just had. This is called a dot plot. Again, it's for the same data. So for this data, so we say, well, this, I think the smallest number is maybe 12. So we put a dot for the 12, then we look for the next number. So I see a 13, 1. So there's 113 here. Then I look here, I see a 14 and a 14, there's 2. So if there's 2, I put a dot here and then I put 1 above it. And then 15, there's 1, there's 2. So I put 1 and then 2. And we get this kind of display. And this kind of gives you a feeling for what the audit times are like, how they're so-called distributed, where they are. So there's some way down here, there's some way up here. Most of them we could say are in this area here, say between here and here. So it tells us something about that data, and it's a visual display, and it certainly tells you kind of more than the original data, just the data does. So if I bring back the original data here, so this data, it's very hard to make sense out of it, but once we put it into this display, this dot plot, we can make much more sense out of it. So that's the purpose of displaying it in this way. Okay, so here's another way, another visualization, another way to display the same data. This is the same audit time data, and this is called a histogram. So they say here a histogram is constructed by placing the variable of interest, in this case the audit time data, or percent distribution, on the horizontal axis, and the frequency or the relative frequency or the percent frequency on the vertical axis. So down here on the x-axis, we have the variable of interest, which is the audit time, and we put it in the intervals like this. Sometimes we call these bins. So we'd say a bin of from 10 to 14. We might say the bin length is 4, or a bin from 15 to 19. The bin length is again 4. So anyway, we can say call it a bin or an interval, and then we just determine the height by the frequency or the relative frequency. So here we have the frequency. So the height of 10 to 14 is 4. We saw that there were 4 elements between 10 and 14, so we have a bar of height 4 here. And you can do this quite, not that easily actually, using Excel, but you can definitely do it using Excel. So they say in figure 2.6 shows the adjacent rectangles of a histogram touch one another. So it's a little bit different than the bar graph where they didn't touch one another. Unlike a bar graph, a histogram contains no natural separation between the rectangles of adjacent classes. So we call these adjacent classes. Here's one class and a class next to it, so adjacent to it. This format is the usual convention for histograms. Because the classes for the audit time data are stated as 10 to 14, 15 to 19, 20 to 24, and so on, 1 unit spaces of 14 to 15 would seem to be needed between the classes. So they're saying that here's 14, this only goes up to 14, and this starts at 15. So you would think, oh, there should be a sort of like a space in between each of the bars. These spaces are eliminated when constructing a histogram. Eliminating the spaces between classes in a histogram for the audit data helps show that all the values between the lower limit of the first class and the upper limit of the last class are possible. So that means that it's possible to have some number between 14 and 15. So that's why we don't have a space in between. It might suggest that it wasn't possible if we had a bar that ended, the first bar ended here and the second bar began here and there was a space in between. That might suggest that it wasn't possible to have a value, say, of 14 and a half or something like that. Okay, let's keep going. So let's look at some examples of different histograms. So histograms showing different levels of what's called skewness. So we have this histogram, this histogram, this histogram, and this histogram. So, well, let's take this one first. So this one, we can call it symmetric, right? If you draw a vertical line through the center here, and you fold this piece over here, they match, right? So we say it's symmetric around this line, or about this line, around this line. Okay, but none of the other ones there's no symmetry. There's no symmetry there. So you might think of this one as like starting like this and then kind of pulling this out to the right. So you get something like this. So this is called skewed to the right. Okay, so when we have something that looks kind of like this, which is like this one but dragged to the right, we call it skewed to the right. And here, this one, it looks like this one, but then you drag it to the left. This is called skewed to the left. So they say this one is moderately skewed to the left. This one is moderately skewed to the right. This one is symmetric. And this one they say is highly skewed to the right. I guess it's more skewed than this one. They say one of the most important uses of a histogram is to provide information about the shape. It's the shape or form of a distribution. So this is they use the word distribution here because, let's go back to this one. These are the audit times, and we can sort of see how the audit times are distributed, or where they are. So you can see that there's a lot in here, and there's a little in here, and there's a moderate amount in here, and so on. So we use the word distributed, how it's distributed, where the data is located. Okay? So they're saying these are distributed in different ways, right? This one is distributed in a symmetric way, whereas this one is distributed where sort of some of the stuff is pulled all the way over to the left, or this one is pulled way over to the right, and so on. So let's read what they say. One of the most important uses of histograms is to provide information about the shape or the form of the distribution. Figure 2.7 contains 4 histograms constructed from relative frequency distributions. Panel A shows the histogram for a set of data moderately skewed to the left. A histogram is said to be skewed to the left if its tail, this is called the tail of it, if its tail extends farther to the left. This histogram is typical for exam scores. Is that right? What does that mean? That means that if I give an exam, that maybe there are going to be a lot of people in this range. Maybe this is like 80% or 85%. So maybe I'll get a lot of people here, and maybe not quite as many people here, and maybe about the same here as here, and then a few that are low and lower and lower. So maybe that's true. Maybe it's true that many exams have maybe some shape like that. So they say this histogram is typical for exam scores with no scores above 100%, most of the scores above 70%, maybe this is like 70% here, so we have a lot of scores here, and only a few really low scores. Panel B shows the histogram, I guess this is B, yeah, for a set of moderately skewed to the right, set of data moderately skewed to the right. A histogram is said to be skewed to the right if its tail extends farther to the right. An example of this type of histogram would be data such as housing prices. So maybe most housing prices are around down here, but you might find some that are very expensive, but not too many. An example of this type would be housing prices. A few expensive houses create the skewness in the right tail. Okay, let's keep going. Okay, we'll have to come back to this. Now, let me just ask you one question. If data is skewed to the right, what might you say about the mean of the data? Or what, another question is, if the data is skewed to the right, what's going to be the difference between the mean and the median? Can anybody think of an answer for that?
Professor?
Yeah.
Like I think the mean is smaller than the median.
So he said that the mean is going to be larger than the median. So
smaller.
No, larger.
It's larger.
Yeah, it's larger. Let me just quickly go back here to this picture. Wait. I can't show it, but okay, there. So in a symmetric distribution, the mean and the median will be equal. So let's assume that that's true, because I can't justify that right now. But let's say, I know we're out of time. So the mean and the median are going to be equal here. So if the mean and the median are equal in this one, and then if I take this data and I drag it to the right so that it looks like this, remember the median won't really change much, right, when you get outliers. But the mean is going to change. So that means the mean is going to be dragged to the right, whereas the median will stay basically where it is. Okay, that's all for today. We're finished. I will reassign the homework, and I will also give you a Khan Academy assignment, but it won't be as long as the previous ones have been. Okay?
Professor, I have shared the response code in chat box. Please use that one for your attendance.
Thank you. Please use the attendance. Please make sure your attendance is counted.